Welcome back for the very last lesson of Test Period 2 or Module 2. This is Lesson 6, Find the Whole. Suggested pacing tells us that we have a 90-minute lesson on this one, which means it will likely take us 2 days to get through it in the classroom. The good news is we don't have any new vocabulary terms for this one. So let's get started. Sometimes when retailers mark down prices, they place a sticker on a tag that covers up the original price. Or if you shop online, the website might advertise the percent being taken off everything, and the item is marked down with a new price. You might know the percent discount and the sale price, but what if you want to know what the original price is? For example, a large online retailer recently sold drones for a discounted price. Suppose you wanted to find the original price. This is the kind of things that we're going to learn in this chapter. The sale price of a drone was $50. The website stated that it was 25% of the original price. What do you think you will need to do in order to determine the cost of the drone before the sale? Now, there's a number of ways to do this. Once you get on up into 7th grade, we're going to learn some great algebraic approaches, but somehow I don't think that's what our textbook wants us to do for you 6th graders. 60% of the 6th grade students at Jackson Middle School play sport. If 114 6th grade students play sport, how many 6th grade students are there in the school? You're given the part, 114. You're given the percent, 60%. What you have to do this time is find the whole. Previously, we gave you the whole and the percent, and you had to find the part. Now we're doing the same basic ideas, only we're given the part, and we get to go find the whole. So it says, in other words, 60% of what number is 114. Now when you get on up into the higher grades, we're going to teach you how to convert that into an algebraic expression. Somehow I don't think that's what we're doing today. First clue, the instruction says you can use bar diagrams, ratio tables, double number lines, and equivalent ratios to find the whole. First, let's look at the bar diagram method. 60% of 6th grade students, yep, we said all that already. We're going to move through the slides and see what happens. So 60 is going to be a multiple of 10, and 10 is going to be a factor of 100. So they drew the bar diagram with 10 equal spaces so that they could get, of course, 10 times 10, 100%. From there, they're going to move on to the next spot where they took and shaded 60%. And they know that that 60% is going to equal to 114 students. All right, that sounds good, right? Next thing we're going to do from here is we're going to figure out, well, what is each one of those little boxes? And to find that out, they took 114 and divided it by the 19 that you see right there, and by the 6 that you see right there, and they found that each 10% section represented 19 students. So to find out how many students total you're going to have, what do you need to do? Well, just add 19s in those other 4 boxes, and when you do that, you can add it up to find that the whole is going to be 190 students. So there's going to be 190 students total in the 6th grade. Now that shows the bar diagram method, but there are other good ways you can use to solve this as well. And the textbook does a great job of showing you lots of different ways to get to your answers and allowing you to explore and use what's best for you. The next method they show us is going to be to use a ratio table. And you can see in the ratio table they put up your part on top and your percent on the bottom. And then they said, well, we know that 114 is going to equal to 60, and they put that in the middle because this number right here, that's got to be your 100. So you're going to have to divide top and bottom by something that is going to go give you a number here on the left of 60 that you can multiply by a number so that you can get to 100% on the right of 60. And of course the goal on the left is going to be 10 again. Whoop, that's too far. I didn't mean to go that far. The goal on the left is going to be 10% again. So they divided the top and bottom by 6, just like we did on the bar diagram. And that said, well, if you had 114 to 60, you would have 19 to 10. Notice that the supporting work includes using the divided by 6 on the top and bottom. On the right hand side, now we're going to take and multiply both sides by 10. And then 19 times 10 be 190. 10 times 10, that's going to be 100. So you end up finding out the same exact answer we had before, that 60% of 190 is 114. So you can say that there is going to be 190 students, or 6th grade students total at this school. Method 3 represents the double number line. Now you all know I'm not a big fan of this method, just because to me it seems to take a lot more work to do. But if it works for you, so be it. Once again, they've set up your top and bottom, your number of students compared to the percent. You have your 0% listed to 100%. And what do we know? We know going in that 60%, that's going to equal to 114 students. From here, they said, well, what does each of the 10% sections equal? Well, same thing. They're going to divide top and bottom by 60 and find that each one was 19. And therefore, they start at 19. 2 times 19 is 38. 3 times 19 is 57. 4 times 19 is 76. And so on until they get up to having that same exact answer that 100% of your students, the 6th grade students at the school, is going to equal to 190. So 3 different ways to skin the same cat. Now the final method is going to be to use equivalent ratios, and we've done this before. So for the equivalent ratios, a classmate let W represent an unknown whole and set up the ratios as such. You had 114 the part compared to the whole is equal to 60 compared to 100. Is this going to be a valid method? What do you think? I think it would if you really knew what you were doing. If you knew how to use cross products, this is a wonderful method. But alas, 6th graders don't get to learn cross products yet. And for what we've been doing, this one here is probably not the best choice, because everything we've done, we've had to divide and then multiply to get to our final answers. And it's kind of hard to divide and then multiply and make it look right when you're using the equivalent ratios method. Music makes up 75% of Landon's music library. I guess Landon likes music that sounds like somebody strangling cats while crying about their beer being spilled and somebody scratching their pickup truck and things of that nature. I just don't do country music. If he has downloaded 90 country music songs, how many songs does Landon have in his music library? Now you have a classmate that claims that 75% is less than 100%. All right, I can agree with that. So Landon should have more than 90 music songs in his library. Well, 75% represented the 90 songs, so 100%, that should be a number more than 90. I'm good with that too. I think his reasoning is going to be correct. So let's start off by identifying the different parts of this problem. Well, let's go ahead and look at the problem again. 75% of the library, 90 songs. So what is the part going to be? Well, the part, that's going to be the 90 songs. That's the portion of its library that is music. The whole, well, we don't know it yet. And finally, the percent, here's the clue. It says a percent sign behind it. When you see a percent sign, we call that a clue that you have a percent there, so our percent is going to be 75%. Check our answers. All that checks good. Excellent. Let's keep moving. So let's use the bar diagram again for our first attempt at this problem. Remember, there's several different ways you can solve them. The bar diagram is just one tool on your back belt. So for this one, we have got 100% on the bar diagram. 75% represents its music library, and it's broke down into 25% sections, which works in this case because the total number is going to be 90, and 90 is a number divisible by 3. So how many songs are going to be in each section of his music library here? Well, that is going to end up being 30. 90 divided by 3 is equal to 30. It checks. Moving on to the next one, you can see they put 30 songs in each section here. So how many songs total are going to be in his music library? Well, 90 for here plus another 30 is going to equal to what? That's right, 120. Check your answers. Boom. That's all there is to doing this. That's your bar diagram method, but it's not the only method to skin the cat. Another method is to use the equivalent ratios. Now, I mentioned earlier that if you use equivalent ratios, you had to divide and then you had to multiply to get these. And that is essentially what has happened here. So let me take and pause the recording and make a screenshot so we can actually go into detail about what happened here. So we started off by saying the part 90 is compared to the whole W, and that is going to be 75% out of 100 that you see here. What they did next is they left the 90 out of 90 out of W alone. Excuse me. And then they took the 75 over 100 and they divided it by the largest number that would divide into both of them, which is 25. 75 divided by 25 is 3. 100 divided by 25 is 4. And that is how they got to the 3/4. So essentially they divided here just like I said they'd have to do. You could also refer to that as simplifying the fraction. And I would settle for you doing your supporting work like this, putting a 3 here and putting a 4 there. I'm okay with that. You can't just go boom, here's 3/4 and not have any justification for it. The next thing they did is they said, all right, well, 3 times what number is equal to 90? That answer is obviously going to be 30. And so they said, all right, great, we're good with that. Now we've got the 4, and the 4 comes from the bottom number times 30 is equal to what number? That's going to be 120. So W is equal to 120. This is supporting work. This is a kind of justification I need to see if you're going to use the equivalent ratios method. So going back to our original problem, we can say that how many music songs does he have in his library? 120, and our answer checks. Let's see what else they have in store for us. It looks like they're going to follow that one up with a question of why was he setting up an equation relating equivalent ratios advantageous to us in this example? Well, for starters, it's because 75 over 100 simplified to 3/4 very easily. So that was a good start for it. And using numbers in math and algebra type stuff, it's just a whole lot quicker and easier to do than drawing pictures are. The pictures are great for getting the ideas in your head, allowing you to visualize what you're doing, but when it comes down to speed, you're not going to beat doing things algebraically. Now it's going to be your turn. Go ahead and pause the video for a minute, work on this problem, submit your answer, and see if you're right. You can use any of the methods that we have shown you to solve this problem. Now the problem tells us that Peyton spent 60% of her savings on a new television. It also tells us that that new TV cost $300. So I have two important pieces of information, 60% and 300. And it wants to know how much money was in her savings account. Now I've said it before, given a chance, I'm going to use algebra every time. So I'm going to compare. I know I have 60%, which is 60 over 100, and I know that the amount she spent was going to be $300. How much was her total amount, which we're going to put in for T, that she had in savings prior to spending all that money? That's where we're going to go. Now, first thing I'm going to do is simplify this 60 over 100, and my first step in simplifying it is to knock these zeros on the end out. So now I'm down to 6 over 10, and 6 over 10 will continue to simplify. 2 goes into 6 3 times, 2 goes into 10 5 times, so my new equation is going to be $300 over T is equal to 3 over 5. And that gives me something I can really work with. So looking at the 3 and the 300, I can say 3 times what number is equal to 300, and that number is going to be $100. So on the bottom, I'm going to have to multiply the 5 times that same $100 to find out the total of 500 right there. So what was the total amount she had in her savings account prior to buying the TV? That was going to be $500. The answer to the question does ask how much was in her savings account, not how much is left in her savings account. So we're going to go back to our original problem, put in 500, check our answer, and we are doing well. Alright, let's look at another one. Marissa saved $15 because she bought a sweater that was on sale for 30% off. What was the original price of the sweater? Now this one's more complicated. It didn't tell us that she spent $15 like the last one did. This one told us that she saved $15. And that changes the whole problem. I mean, this is where we get a real mess going on. So, for our think about it, is the whole going to be less than, greater than, or equal to $15? Well, $15 that she saved was 30% off. So, if she's only saved 30%, only saved $15, that means that the whole is going to be a whole heck of a lot more than $15. Now this is where I'm going to stop part 1 of this recording. Make sure you come back and watch part 2 so you understand how to solve this problem. It's a lot more challenging than what we've been doing so far. You need to watch the other half of the lesson.